Hi guys, welcome. We'll get started now. I'm Mariah. Glad to meet you all. I am representing MX today. Usually Garrett does, but today I'm representing MX. I also am one of the organizers of this meetup. So we're super glad to have you here today, and we're super glad to have Matt speaking with us. We're glad you could come out after Thanksgiving and that we can have one more meetup before it gets Christmas crazy. So super glad. Just a couple of announcements. First one, we just want to thank our sponsor MX for giving us a space and providing pizza and drinks. I just Slack people and they schedule rooms for me and buy pizza, so I don't do any work. So thank you, MX. If you have not joined the Forge, so Forge Utah is a nonprofit. They run a bunch of meetups. We are under their umbrella of meetups. So is the Utah Data Engineering Meetup, Kubernetes Utah, there's one in St. George, Utah Engineering Leadership, and Utah Go. There's also a GitHub and a Slack community. They provide a whole bunch of stuff. If you would like more information about our meetups, you would like to participate in community chats, there's been lots of sharing of Twitter threads about ML stuff. There always is sharing of Twitter threads about ML stuff because Twitter. I don't know what X is, so I don't know if I accept X as an existence. If you would like to join Slack to stay up to date with all of the fun stuff, you just go to forgeutah.tech, the website. There is a button. You click that button, you become a member. Super nice. And then you can, hang out and chat with me. And then we will not have a meetup next month because we do not want to have a meetup on the 26th of December. So we will skip December and we'll be back January 23rd for the first MLOps meetup of 2023. So that's what I meant, 2024. So if you are not following us on Meetup, follow Forge on LinkedIn, join the Forge Slack. I don't post on Twitter, so LinkedIn or Forge Slack, and you can stay appraised of our next year events. We'll have lightning talks and speakers. Chris is going to start helping co-organize. Chris right there with the beard. And because he is a machine learning expert, he will be much more proficient than I am at finding speakers. Lastly, we do have pizza in the back and drinks. Please feel free to get seconds or thirds. And then at the end of the meetup, if there's still pizza, grab a box, take it home. Because it goes home with me if it doesn't go home with you, and I live alone. So that's the story. So without further ado, we will turn the time over to our fabulous speaker, Matt Harrison, who usually is busy. Every time I've asked him to speak, he is teaching courses and presenting live and doing all of these things. He's written or writing books, very busy. So he has joined us today to teach us about polars and data manipulation, which I'm a data engineer, but I have no clue what this is. So I'm excited to learn and turn the time over to you, Matt.
Do we have this or a clip on, or we're good to this? Yeah, if you have a clip on, that's easier. So I don't know if you guys can see over here if you want to relocate or whatever. You guys are okay over there seeing? Okay. So while the clip on is coming, who all here uses Python? Okay, everyone uses Python. Is anyone using polars here? Okay, one person. Is anyone using pandas here? Okay, most people. Has anyone never heard of pandas in here? Okay, just trying to figure out where our audience is. Cool.
Yeah, put it on the file.
So are most people doing like, just shout out with some job titles of what people are doing in here. Data engineer, okay. machine learning engineer. Product analyst, okay, student. Recruiter, okay. We covered everything? What's that? Machine learning? Okay. Developer? Okay, cool. Awesome. So yeah, my name is Matt Harrison. Do I need to do anything else or we're good? Like, you're good, okay, awesome. Okay, so a little bit about me. So here might be some relevant background. So in around the year 2000, I started doing, I graduated from school and started using Python for doing natural language processing. So the company I was working at was doing search back then. This was before tools like Spacie and NLTK came out. Later on, in 2006, I made an OLAP engine for Python. This was before a lot of columnar databases existed. So we kind of hacked on like materialized views and OLAP cubes on top of Postgres using Python, which was fun. We messed around with a database called MonadDB, which was like a academic project for columnar databases at the time. And so I'm actually a committer to SQL Alchemy because I wrote the MonadDB SQL Alchemy interface way back when. 2009, I heard about pandas, and then I started using it for work because it was doing a lot of the things like this OLAP engine that I created but did some things smarter. And then ended up writing a couple books on pandas. I wrote a book called Learning the Pandas Library. I wrote the second edition of the Pandas Cookbook, and then I wrote a book called Effective Pandas. And just today I went through, I think, hopefully close to the final draft of Effective Pandas 2. So that's exciting. Did a little bit with Spark in the meantime, and then also messed around, have taught courses on QDF, which is a GPU library that implements the Pandas API. I was an advisor for a company called Ponder. Ponder made a Pandas API compliant interface for basically taking your Pandas code and pushing it into Snowflake. So you just change the imports basically, and then instead of running on small data, you can run on big data. And so here we are with Polars now, and I've been messing around with it for the past year or so. So what I want to talk about here is just, I'm going to go through a little bit about Polars. I'm going to do an example of Polars, and I'm more than happy to take questions or heckling before, during, or after. So if you have a question, just raise your hand. Happy to address questions that you have. So Polars. So I guess so Pandas came out way back when, and Pandas has good things about it and has bad things about it. And I make my living, like I like to say, I make my living selling snake oil and teaching people to tell lies with data. But I spend a good deal of my time teaching people Python and then teaching them how to manipulate data with Python. And as an educator, I think it doesn't leave a good taste in my students' mouth if I'm like, oh, rah, rah, Python, and we go through this little course and everything's awesome in Python, and then they get out in the real world and they're like, Python sucks, I can't do anything, but it worked when Matt did it. And so obviously I'm biased, but I hope that I like to show the warts to my students and expose them to them so they're kind of inoculated against that and know how to overcome them when they run across them inevitably later. So Pandas has a lot of warts. And this isn't a Pandas talk, but you can think of polars as somewhat as an answer to a lot of the warts of pandas. The creator of pandas describes polars. So the creator, Richie Van Kees, he's from over in Europe. He describes polars as a query engine with a data frame API on top of it. So in short, Python, everyone here is using Python, so you all know that Python is a slow language, but for some reason you're using it, right? And it's kind of odd that we're using this really slow language for things like machine learning when Python's really slow. And sort of the dirty secret to pandas was that pandas basically encapsulated this NumPy library and gave us a nice way to mess with structured data and columnar data that doesn't have, that's heterogeneous columns in a way that's a lot nicer than just writing C code. And so as long as you kind of play inside of that playground, inside of like the pandas layer that sort of pushes everything down into NumPy, you have relatively good performance, memory consumption is relatively good, but there are drawbacks to that as well. So Polars basically says, okay, we're gonna throw out NumPy as the backend, and we're going to basically write our own query engine in Rust. And so one of the nice things about Rust is like you can do like multi-threaded operations. And so basically Polars, the Rust part of it basically has a bunch of worker queues that basically says, okay, you've got 10 CPUs on your machine. I'm gonna have 10 queues here. We're just gonna throw work into those and we'll just max out those CPUs and pull work out of them and do that. And then you can shovel work onto that using Python. So Pandas isn't really great with multi-threaded. Another thing that Polars has, and I don't know where I'm going to this backwards, but Polars has query optimization. So if people have, some of you have played around with databases, but databases have like decades of research behind them where people have like thought, oh, we can do these things like predicate pushdown and projections, and when we're doing a join, we can filter first on the right-hand side and figure out that will make our join faster. And it can do that because when you write a SQL query is lazy. Like the engine, whatever, Postgres or DuckDB or Oracle will take your SQL and it will basically run it through this compiler that knows about your data and knows about what order of operations to do things in to make it run faster. And Pandas doesn't do that. Pandas is, so we would call that query optimization, but also it has to do with this laziness. Pandas is eager, right? So when you tell Pandas to do something, it just says, okay, I'll go do that. And if you have a bunch of operations, it just does those operations. And there might be a faster way to do them or an order that's different that might be faster. Pandas doesn't do that, but Polars does. And yeah, so Polars, like they said, it's or the creator said it's a query engine with a data frame API. I will say one of the things that's different about Polars, if you're familiar with Pandas, is the API is pretty much different than Pandas. So if you're familiar with the Pandas API, which is basically like the lingua franca of like tabular data, I would say in like the machine learning world, like most people who are working with tabular data understand Pandas to some extent, so much so that like there's probably a dozen libraries that have implemented the Pandas API. I mean, Google has a library that just came out that does that. Like I said, this company that I was advising did that for Snowflake. Modin does that. QDF does that, right? So the Pandas API, for better or for worse, has basically become the lingua franca of data manipulation, and Polars doesn't really support that. Polars has its own DSL, so to speak. And so what Polars, to enable a lot of this, it uses what it calls expressions. So whereas with Pandas, you have like a column or a series that represents a column, and you do some operations with that. In Polars, instead of saying, here's a series, you say, here I'm going to build up this expression and it represents a single series or multiple series, and then I'm going to chain a bunch of operations on that, but that expression is basically like a Python object that it can be compiled down into some operation behind the scenes. And then there are these contexts that you throw expressions into. So that's kind of an overview of polars, but basically the gist of that is by doing things intelligently versus naively with pandas, you can get a lot of speed improvements. So I'll just break here. If any questions or thoughts? Okay. Yeah. Mm-hmm. Yeah. So the question is like, there's no way there. I'm gonna maybe tweak this a little bit. You can tell me if I'm throwing words into your mouth. The question is NumPy dumb, and is there a way to make NumPy smarter about maybe CPU utilization? Yeah. I mean, NumPy has some smarts in it. It does have some flaws, but again, one thing to be aware of is like NumPy is sort of like pandas in that, like, if you're doing linear algebra or numeric manipulation, that's kind of a library that a lot of people are using or learning about, right? And so even like NVIDIA has a library that basically lets you take a NumPy array and swap out the import and run your NumPy code on a GPU. Same thing with pandas. And so like if you do whatever, some text operation in pandas, it's going to be super slow because pandas 1 doesn't have really good support for strings. But if you throw that onto like NVIDIA's GPU library, which implements the pandas API, you can rename the strings and it will do it like 600 times faster because it will take each of those columns and say, I'm going to run each of these 600 strings at a time, right? Because it's going to use each of those processing units to do that. And so, yeah, I mean, you can speed up NumPy doing tricks like that, right? But NumPy, you know, it's an older library, but has its good things and it has its bad things. And again, the kind of the key thing to be aware of when you're using NumPy or pandas or even polars to the extent is that, like, again, we have this slow language and then we have like this core of things that is fast or can be fast. We want to minimize kind of poking through that to go from the fast side back to the slow side. So generally for so I'm going to go through some examples here. I'm just going to import. So if you want to install polars, you can just say pip install polars. I'm going to import polars as PL here. Let's make sure this works. Okay. And so I was looking on the internet. So yeah, another thing. This is version 0.19.12. I don't think this is the latest version of polars. So that might be another thing. Like, this doesn't have a 1.0 release, and it releases relatively fast, like maybe 2 releases per month cadence. And they're not necessarily super concerned with backwards compatibility, so to speak. So just be aware of that. Like, that may or may not be an issue. Like, people are like, should I adopt polars in my enterprise? You know, if your enterprise is relatively conservative and doesn't like things breaking, maybe not, right? So it's not I guess stabilized from that point of view. So I wanted to find some interesting data about like DevTernity or, I don't know, OpenAI fallouts, but I couldn't find anything that was like useful. I like tried to scrape the DevTernity conference website for anything interesting, and it was like there's 10 speakers and all of them have dropped out. So I'm going to instead load my Twitter data, which may or may not be interesting, or X. So I'd done this a few years ago for pandas. Like I took all my Twitter data and like did like machine learning on it to sort of divine how to beat the system, so to speak. So I reloaded a lot of the data today, and it turns out that like if you're on Twitter and you want to load your data, apparently they don't keep it for more than a year and a half. So I have like a 6-month gap in my data. I have like the first half of 2022 is missing, but I have like 2000 and 2020 and 2021. Anyway, so here's just some code to load it. We'll just kind of ignore this here. This is just loading sort of the raw data. So I'm just going to sort of ignore that here. But this is what the data looks like. It's got, so again, this is straight from Twitter. It's got like a tweet ID, a text, and a time here, and then like how many impressions and how many engagements, and then engagements rate is like the engagements divided by impressions, and then a bunch of other things that most of these are blank or missing. So that's what we're going to look at. I'm just going to go through this data here. So here's the columns that are in here. There's a bunch of like promoted stuff. I haven't paid. I mean, I have a professional Twitter account, but I don't pay for promotion. So those are all missing. But if you read this in, it's like 4.3 megs of data. So this is not very big data, and so maybe not particularly interesting as far as like flexing sort of the cool features of polars, but it is what it is. Now let me just talk about data size for a little bit. So at a broad level, I'd say that we have like small data, medium data, and big data, and people can like fight about what those mean. Basically, for me, small data is something that would fit into RAM. Big data won't fit onto a single machine, and medium data is data that won't fit into RAM, but maybe fits onto your disk. Okay, so Pandas, the library, is decent at small data. If you're using Pandas, it has to fit into RAM. Things like Spark are good for like big data, but kind of, I mean, you can use Spark for small data stuff, but it's kind of overkill, especially with technologies that are out today, and it's going to be super slow, and you're going to be paying a lot for not much. And then you have, things like QPy, which takes your Pandas code and runs it on the GPU. So, I mean, that's kind of small data-ish. And then you have things like Modin and DAS, which will scale out your Pandas code to a cluster. So that's kind of big data for Pandas. Polars gives you basically small data plus some spillover to medium data. So it has the ability to spill over into medium data. It doesn't really have a big data story right now. So that might be another thing to take into consideration, but it seems like a lot of people are now like anti-big data, and they're like, everyone built out these Hadoop clusters and Spark clusters and didn't have anything running on them, and now they have all these like laptops that they can put their data on. So Polars kind of fits into that small, medium place. Okay, so here's our columns here. I'm just going to select a subset of those, and here's the types of those, or at least these are types that Polar says when I did that. So this is like 2.8 megs. Let me just talk about types. In short, again, these aren't Python types. These aren't even NumPy types. These are, well, another thing about Polars is so it has under the covers, it stores data in a format that's called the arrow format. So the arrow format is basically a standard that the creator of Pandas made, which is like, this is an in-memory format for storing tabular data. So it has defined structures and layouts for like integer data, string data, float data, and other types of data. But this is the data that came in when we read the CSV file. So, and does anyone here deal with the CSV files? Okay, I'm sorry. CSV files are good in that they're like human readable, and that's about the end of the goodness of them. Like they don't have type information. they're kind of flaky, and there wasn't really a standard until after the fact when the standard really didn't matter anymore. Okay, so I'm just going to walk through like a process that I would do if I got this data, and hopefully this will show you some of the features of polars. So this kind of looks like pandas here. I'm going to say DF, and I'm going to say columns in there. That's going to subset the columns in there. But then I'm going to say select here. So select is what polars calls a context, which again is a little bit different than pandas. And then inside of this, I'm putting this expression here. So I'm saying I want to pull out a column, or columns plural, and note that I'm not giving it a name, I'm giving it a type. So this is going to say pull out everything that is an integer type in here. And so this gives you something that looks like this. So if you're familiar with pandas and Jupyter, this should look pretty similar to you, except one thing you're not seeing is this thing on the left-hand side that you would find in pandas, which is an index. Polars doesn't have an index. It also doesn't have a series. It just has basically a data frame. So again, looks pretty similar to pandas. The output here, it tells you the shape at the top there. And it actually tells you the size or what types these columns are there as well. So these are the integer columns from this tweet information here. Now, like pandas, it does have a describe method, so we'll run that. That's one of the first things I like to do just to understand my data. And this gives you back a data frame. Again, there's no index here, so it just makes a column called describe, and that's a string column. And then for each of these numeric columns, it's going to give you summary statistics. So it calls count the number of rows and then null count the number of missing values, which is a little bit different than pandas. Pandas calls count the number of values that aren't missing. And then you have mean, standard deviation, minimum, maximum, 50th percentile, which is also the median. So I like to just go through this and like check out what's going on here. Like this is using a 64-bit floating point number, or no, that's not a floating point. These are all integers. So these are all 64-bit integers. It says floating point because the summary statistics have decimals in them, and it wants to keep the column the same. So the types up there are not the types of the original column, they're the types of the summary statistics here. But if you look at these are all in 64 columns. This one's like 1.7 times 10 to the 18th, so that's pretty big. This one's going up to 8, right? So apparently, like, very few people have opened their apps from my tweeting. Very few people have installed from my tweets. You know, I've got like 191 followers from a tweet, which I think that's broken, but I'm not quite sure what that is. And then like media views, 16,000. So yeah, it's using 64-bit integer to read all this because CSVs are kind of dumb. And so maybe I want to shrink that. So I'm going to show how to shrink it. I'll make a meta commentary here. I would not write this like this. I would write this. This is the same code. I would just write it like this, though. So we call this chaining. So I'm going to put the parentheses around this. In Python, white space is important. When you put parentheses around it, whatever happens in the parenthetical, it ignores white space. So what I like to do is just put each of these on its own line. What that allows me to do is it sort of forces me to write this like a recipe. But also makes it really easy to like debug what's going on here. So here's my original data frame. Here I'm selecting the columns that I want. Here I'm further selecting the integer columns from that, and then I'm doing a describe on that. So it reads like a recipe. So if you're using pandas or polars, I highly suggest that you write your code like this. Your future self and your colleagues will thank you once they understand how nice this is to write code like that. So let's just go through, you know, can something be an int 8? The PyArrow library doesn't really have this, but NumPy does. There's this IInfo, which is integer info. It just tells you the range of integers. So an 8-bit integer can go from like -128 to 127. So like these two, we could make those 8-bit integers. Probably couldn't do that with follows or these other ones here. But there's also a uint 8. Which is an unsigned integer, which goes up to 255. So I'm not aware of like, I mean, maybe it's possible with Elon, all of his antics, to like have negative app installs from a tweet, but I'm gonna say it's not currently. maybe that's a feature that he's going to add, but we could do something like this. We could say, okay, I'm going to subset my columns, then I'm going to say this with columns. This is another context here, and then I'm going to put an expression in here. So again, this PL call here is not referring to the data series, right? In pandas, you would pull off the column and refer to the column itself. This is just saying, I'm going to make this thing, this is expression, and the name of the column is follows. It's not, doesn't know anything about the data frame. Okay, and then on this, there's a bunch of things you can do. One of those is you can cast it to a different type. So we're gonna say, take that and cast it, and then we'll do a describe on that. And this looks pretty similar to what we saw before. We didn't lose anything when we did that. So what I'm gonna do is I'm just gonna build up a little chain here, and I'm gonna say, okay, I want to say with these columns, convert those to uint8s, and with these columns, in this case it's just the one, convert that to a uint16. And you do that, and our size goes down, and we don't lose data. Note that if I tried to do this with like a uint8 here, it complains. And it gives me a panic exception. And you know, so this error is kind of weird. It used to be smart, so I don't know, recently Polar's changed something, but it used to say like, this number is too big for a uint8, and now it just gives me some panic thing. So maybe they optimized it and made the errors worse. But you can see that I save a little bit of data when I do that, right? And that might be important for you if you're dealing with small data, things that need to fit into your RAM to do that. Let's look at strings. So I'm gonna do the same thing here. I'm gonna say like, let's select the UTF-8 strings here. And so what do we got? We got like the permalink. This is like some URL, and then it has the ID on the end of it so someone can link to that. This is the actual text of that. And then this time one is actually not a string, but it's a date, but for whatever reason, because it's a CSV file, it came in as a string. So I'm going to, so here's what we had before. And so I might do something like this where I say, okay, let's convert this to a categorical, right? And so one of the things that this arrow representation did say, here's a smarter way to store strings for tabular content, rather than like, again, NumPy doesn't have a smart way to store strings. So in Pandas 1, basically when you stored a string column, you basically had an array, a NumPy array that pointed back to Python strings. So it wasn't, you didn't get any improvement over just like writing a list of Python strings in it, other than you had some nice convenience functionality for like operating on the whole string, whole series at once. So categorical is something that you can, depending on the cardinality of your data, can save you a lot of memory. So basically, if you know about databases, this is like normalizing your column, so to speak. It's like saying, we've got this normalized column that we have an ID that points to it, and instead of having, 50 repeats of the same thing, we only have one, and the ID points to it. In this case, like, some of my tweets are the same, but none of the permalinks are the same. So if I do that, it will convert those to categories. But in this case, I actually lose functionality. Well, I'm penalizing myself for doing that, because the cardinality is not such that I actually save memory by doing that. Let's look at something else. I'm gonna pull off, like the permalink looks like this. I could store this, I already have the ID here, but let's assume that I didn't have the ID. I might wanna say, okay, let's just rip off the ID here using a regular expression and store the ID rather than everything in there. And so, again, this is what I had before. This is my chain before. I'm gonna say, okay, so this is one thing that you, like in Pandas, if you're used to like Jupyter, you can just like pull off a series and kind of play with it. A little bit harder to do that in Polars because it doesn't really have a series. So I'm just gonna make one of these expressions here so that I can like do tab completion on it, right? So I can come in here and I can like say, what are the things that I can do with this expression? And these are the things, and like Pandas, it does have a stir on it. So some of it is modeled after pandas, and here's like whatever 200 things that you can do on the expression itself. So again, you can pull up the documentation here. Documentation, I would say, if you're familiar with the pandas documentation is relatively good. I would say that the polars documentation in Python is not quite as good as the pandas documentation, but it's decent. You know, it has like, here's what you pass in, here's some notes. It's not quite as old, that's true. I mean, I don't know that, yeah, I mean, oldness maybe has something to do with it, but I would imagine the developers, given like the rapid state of flux of things, they're more focused on other things than writing documentation. So again, that just might be something that you should be aware of if you're thinking about adopting this. So, so here what I'm doing is I'm saying, okay, let's do with columns. So select is going to say, here's the columns I want. With columns is going to say, I want you to add a new column. So I'm going to say, you know, overwrite these other ones, convert those types. We already did that. And then here with tweet permalink, it has a stir accessor. And I'm going to say, I want to extract any digits in there, regular expression, pull those out, cast those to an integer, and then alias that as the ID column. So if I do that, I have this ID column here at the end here. And you can pull off the size here and see what that does to you. So again, if you just want to like work on that, you can do this instead. So this first one up here is just putting that into the data frame. This one down here is pulling off that single column with a select instead of a with columns, and saying, okay, select this with this expression in here. And so this is kind of doing the opposite. It's saying, here we're pulling off the digit, here we're pulling off the rest of this. Not particularly interesting with this data set, but you know, you might want, I have data sets that are kind of messed up, and using a regular expression can be nice to access those. So here I build up this little chain. It might look like this, where, you know, here's my cleaned up data a little bit, and maybe I'll do a little bit more after this. So one thing that people do, anyone here use drop in pandas to drop columns? Okay, so polars has a drop as well. And so actually, like a year ago, I was talking to the creator of polars. He said, I want to talk to you because I was doing a course on polars, and he's like, I want to see what you're telling people, kind of, but also like going over what I had some questions about polars. And so when I was going through my content with him, he's like, oh, you're using drop. That's kind of bad for polars. Like, why is that? Well, he's like, well, because our query engine wants to know about what it's working on. It wants you to be positive about what you're working on, right? So it knows that you are using these columns. Versus when you're saying drop, you're saying, I don't care about these columns, so get rid of them. And so anyway, you can get some performance improvements by being smart about that. But also, if you look at this, I think this goes back to like just being smart about like writing code that other people can use. At the very end here, I'm going to say select the final columns. And here I'm being lazy, I'm using a list comprehension, but I could manually write out what columns I want at the end. And then when someone comes to my chain here, they can look at this last part and they can say, I know this is exactly what's going to come out of this. It's a data frame with these columns. Versus if you put a drop in there, it's like, I know it doesn't have this column, but I have no clue what anything else is in there is. So it's just a small little tweak like that. Like polars can be smart about that. Here what I'm doing is I'm just dropping out that permalink column in here. And when I do that, it turns out that permalink takes a bit of memory. So I save quite a bit of memory by doing that. This data doesn't have really missing data because I've subsetted the columns here, but there is like fill null to like fill in missing values. You can filter rows with filter, and you can select columns with select. And you can do something like this, filter and say, you know, is this column null? And that would show you all of the rows where that column was null there. So I'm just going to say null count here. This is the same chain that I have above. We'll just do null count. And basically, there aren't any missing columns in there. So we're lucky with this data set. Let's look at dates here. Maybe I'll break for questions at this point. Pandas versus polars. Oh boy. So this is the money question. Like, when do I use pandas versus polars? Depends. I mean, that's your typical data science response. Depends. Yeah. So here's my take on it. Sample size 1. Like I said, pandas the API are sort of like the lingua franca of data manipulation in the data science world. So, 90% of data scientists probably know or use pandas, right? And a lot of these people are somewhat finicky about changing tools. So, I mean, I would say maybe at this point you could think of like no one ever got fired for buying IBM. That might be a little old for some of you, but used to be a saying that like IBM's around and like people can use IBM and it's like the safe bet. So I'd say that pandas at this point is maybe the COBOL of data manipulation languages. I don't think it's going anywhere. You've got companies that have thousands, if not millions of lines of pandas code, and it works, it makes them money, so they're not gonna like move to that, right? Or move from that, or most sane businesses don't rewrite code just for fun, right? Rewriting code doesn't pay bills generally, unless there's a big reason to do that. So why would I use polars? Polars is quite a bit faster, right? And depending on your data set, it can do things 100, 500 times faster than pandas can. So that may or may not be important to you, depending on what you're doing. Again, polars is not stable. So that's kind of a big red flag for a lot of people who want to, do machine learning or process data. It's like, oh, I have this thing and I have to rewrite my code or fix bugs every time I reload it. That might be annoying. That kind of give you some answers. Learning curve is different. Yeah, the API is different. I would say another thing is there's like the Python, the PyData, I guess, the ecosystem of PyData kind of like wraps pandas right now. There is a data frame interchange API that folks are supporting. So now like scikit-learn, I think in the next release will work with polars. Most of those tools behind the scenes are just converting things to pandas and then running it to pandas. But with pandas 2, so pandas 1 I would call legacy pandas. Pandas 2 has the ability to sit on top of Arrow instead of NumPy. And so because of that, you can basically do a zero copy from a pandas data frame to a polars data frame and back and forth. So that's kind of nice. Yeah, numbers there as well. Question is it 500 times faster? Yeah, it can be 500 times faster. You can do some really dumb things in pandas. You can do some dumb things in polars as well. I mean, again, the main thing is like you've got this core that's I would say the Arrow or the NumPy core, and you don't want to be crossing that boundary going back to the Python side. But again, the core in polars knows how to do things like query optimization and knows how to like max out your CPU and might be a little bit smarter about handling strings than pandas, so it can do things a little bit faster. Okay, great questions. Okay, so let's look at our dates here. We've got this time thing in here, so I'm just going to say, let's cast that as a date. And I get a compute error. And you can come down here. This one's a little bit more useful. It says like strict conversion from string to date failed for these values here. So people who have messed around with this in pandas, it's kind of a pain in pandas as well. Like dates are kind of a pain in most programming languages. And things like daylight saving times and other things are weird. So instead of just casting it, I'm going to be a little bit more smart and say, okay, this is like the stir time representation for that. So we'll run that here and this spells. And anyway, long story short, it turns out that like the format that I was using for my old data and the new format are different. I don't know if that's my fault or Elon's fault, but anyway, they look slightly different. And so my stir time didn't work. So I'm going to stick in a chain in here, and I'm going to say, okay, before you do that, replace this space plus 0, 0, 0, and just get rid of that. And then if you have this form, get rid of that as well. And so the literal here means this isn't a regular expression. It's just like a straight up string replace. And then with that, convert that to a date. Man, cross my fingers, and that works now. So you can see that this is now a date time. Okay, and again, I did put that select at the end there, so I can come up and look at my columns. If I want to convert that to Denver time zone, I need to first tell it to throw it into UTC. It's kind of naive right now. And then after it's in UTC, I can convert it into Denver. And now it's in Utah time. Okay, so at this point, I've kind of gone through a lot of my columns and cleaned them up. So this is the same thing I would do in pandas. I do this in polars as well. I'd make this function here. So this function takes my raw data, and it's basically a pipeline for cleaning up my raw data. A lot of people take issue with that, or like, why are you cleaning up your raw data? Well, I don't know about you, but generally, like when I do some report or make some analysis, the boss comes in and asks me like, why do you say that, right? And I got to go through and like look at someone's handmade Excel spreadsheet and figure out why they changed something, or like find some file somewhere, or walk through some weird notebook that has 300 cells that you have to execute in some arbitrary order to get it to work. So if I just put it in this chain, it's all in one place. I can come back to it, I can read it. This actually tells me like every step what I'm doing here. This is a little bit small. I mean, I've made chains that are a lot bigger, but this is nice. I can come back to my notebook. All I have to do is load my raw data and then load this function, and I'm good to go. So I would recommend, if you're using pandas or polars, once you've gone through a process like this, at your notebook, make this function, throw it up to the top, especially you who are like data engineers, right? You're putting software engineering behind data science, like bad practices. So this is like a good practice, and then it allows you to test your code and makes your life generally a lot easier. Okay, yeah, and then at this point, like we're about half the memory when we've done this little process here. Again, this is not a huge data set here, but you could imagine, if someone's saying, okay, I've got some beefy laptop and it's kind of pushing the edge of when I might want to use Spark or Snowflake or something, but maybe I can rent an expensive computer. If you can do it on a single computer that's smart, like polars, generally it's going to run 30 times faster than Spark is. So you can get some pretty big wins from doing that. So this is 1.8 megabytes. So this is bytes. So there's kilobytes, megabytes. Okay, other questions? Okay, so this chaining here again, like this is something that I've been pushing in pandas for a while. If you've read my pandas book, you know that I do that. And when I post code samples on LinkedIn or Twitter, people go crazy. They're like, this is the most horrible code that I've ever seen. My eyes are bleeding. I would never accept a pull request from you, stuff like that. I should collect the best of comments of my code. Anyway, I get it, like it's weird if you've never done it before, and it looks weird, and like people are like, that violates Demeter's law of programming and things like that. I'm like, I don't know about that. But people seem to have no problem like writing huge SQL queries with CTEs in them and whatever. But for whatever reason, when it's like code, they get upset. I don't think you have to, like, it's not mandatory to write things in chain. I think that a chain in pandas is going to make your life easier. It's going to make your code easier to understand. It's going to make your colleagues' code easier to understand. It's going to make it easier to come back to your code. The thing about polars is that you actually get performance benefits from chaining, because polars has a query engine, and you can run polars in lazy mode, and it can basically optimize what's going on and improve the speed here. So this is kind of not a great example, but if you use the scan CSV instead of read CSV, it's going to put polars into lazy mode. And basically what that's saying is saying, I'm not going to read the CSV file. I'm just going to say, this is a CSV file that I'm going to read. Okay, and then you can chain all these operations on this. Now it turns out that I'm using an operation here called vstack, and vstack isn't able to be in the pipeline. So tools like DuckDB would call this a pipeline breaker. Like there are a bunch of operations that you can do on data frames or tables, and sometimes those operations, you can't be smart about them without materializing some of them. So like DuckDB calls that like a pipeline breaker. So like vstack is an example of this. So before I call vstack, it says like, if I were to call this and I comment out this, I think it says like lazy doesn't know about that. Yeah, lazy frame has no attribute vstack. So I stick in a collect in front of that, and that materializes that at that point. But I can like be lazy about this whole thing here, and if you're lazy about it, you can see that right here. So I've got get lazy frame. It does materialize at this point, but actually I make it lazy again at the bottom here. And then I pass that lazy thing into this tweak Twitter lazy. So it's all lazy about this. It actually doesn't materialize. When I call this, it just returns a query plan. And this is the query plan. This one isn't particularly interesting because it's not like really able to do a lot of things that are smart. Generally, when you start doing group bys, it can be a lot faster. So this isn't particularly interesting, but it just shows you that, yeah, this hasn't done any of this. It's just, this is what it would do if you wanted it to. You can stick on a collect here and tell it to stop being lazy and materialize that. And then it will run that. So supposedly, if you run that, I didn't do the timing here, but this would be faster, or possibly could be faster than doing the lazy mode of that. Okay, another thing that people complain about with chaining is like, how do you debug all of your code when you chain? And hopefully you saw that like, I don't come to like data and just say, oh, here's this big chain, I'm just gonna write a big chain and then like throw it over the cliff and hope that it runs, right? That's called like waterfall style programming, and people are more agile these days. Like you saw me, like I built up the chain as I was going through it, right? I did one thing and then I didn't just throw that away and do something else. I kept what I was doing and then I added more to it. You see that I'm building that up. You can do the same thing with pandas. So that's generally how I work. I just build it up and I'm sort of testing it, inspecting it as I'm going. Some people that bothers them. They're like, well, you don't have the intermediate variable. I'm like, yeah, I don't. And they're like, how do you know it's in the intermediate variable? Well, I checked it as I was going, but I don't really care about the intermediate variable, right? Like when I'm running a SQL query, I don't care about what SQL is doing on the covers. I care about the end result. But whatever reason, this kind of makes people upset here. So, you know, if you want to, you can debug this. It's really easy. I mean, you basically comment out the chain and you can walk through what's going on in that, right? Alternatively, you can do some other things as well. So there's a pipe method in here, similar to pandas. If anyone use pandas pipe? So that's a method that you should get familiar with if you're chaining. Anyway, so pipe, you can pass in whatever you want into it, and it just takes a data frame as the first parameter and can return whatever it wants. So if you're taking a data frame and return a data frame, you can continue chaining with that. So here I'm saying, let's just make a pipe here. I'm going to call the get variable here, and I'm going to pass in a variable name. In this case, it's df2. And this is just hijacking pandas globals, and it's just making a variable called that variable name. So if you want the intermediate variable, you can just stick in this code here and get the intermediate variable anywhere that you want. Also, I've done like a few more pipes in here. So this is a pipe. And I'm just saying, here's a lambda here, and I'm just gonna print the shape and then do a short circuit to say shape for this, and this will return the data frame, and actually stuck that in a couple places here. So when I run this, it just tells me what the shape is of the data frame as I'm going through this operation here. Again, this isn't doing anything fancy, but you could imagine if you're doing a merge or group by, right, you might want to be aware of if you're doing like some combinatoric explosion that like you don't end up with 1,000,000 rows when you're expecting 50 or something like that. So this is the output down here at the end. I mean, you can see that the last part of this is a pipe, but because it's short circuiting and returning the data frame, it returns the data frame there. And then I can come down here and, for those people who want that intermediate variable, there it is if you want that. Again, because pandas and polars are small memory, small data tools, depending on what I'm doing, it might make it so I can't run code if I keep around these intermediate variables. So this is just a nice way to not have to deal with those and not have to like clean up that mess. Okay, questions about that? Questions you have? Okay. Okay, another thing that people, this is another pet, sounds like I'm just ranting. So another thing that you'll see like all these blog posts, it's like top 20 things you should do with pandas or whatever, and I assume you'll start seeing these with polars as well, because apparently people click on things like that. And one of the things it says is like, there's this apply method. Anyone used apply here? Okay, like it's the queen's bees or whatever, or the queen's knees, or, you can pass a function into this apply. And people are like, oh, that's so cool. Like I can do this thing and pass a function in there. The issue is that when you're doing that, you're taking your code out of your fast little shell here and you're passing it back into like a Python function. So it's actually really slow. And generally the examples that you see online are horrible examples where you shouldn't use apply. And so I think it just sort of, I see a bunch of code using apply all over the place where it's like, that's really slow and you shouldn't be using that. So anyway, polars also has the ability to do apply. So I'm just gonna run my code here, okay. So let's imagine that we wanted to calculate this engagement rate, right? So to do that, we take the engagements and we divide it by the impressions. It's already on there, but let's assume that it wasn't on there. We could do something like this, or in pandas, you do something like this, where you'd say like, okay, I'm gonna pull off these two columns, and polars, it calls it map elements instead of apply. I guess they figure like, if you read that it says map elements, you might think that, oh, I shouldn't use this because it's mapping it over the individual element. It's not over the series or the column there. And this complains, it says like it requires one positional argument. So it's actually kind of difficult to do row-wise. Like in pandas, you can just say I want to do apply on axis is equal to 1 or the columns and do a row-wise application. In polars, what we do is we throw it into this struct. So part of the PyArrow is that PyArrow has nested structures in it, and one of those is a struct. And so I'm going to say, I'm going to make a new column that's composed of these two columns. And then once I have that, I can call map elements on that. I don't know why it's calling B here. And then this is going to get a dictionary in there. And it turns out that there's a divide by 0, so I'm capturing that as well. And then I'm just printing out the engagement rate here to sort of check that those are the same. Lo and behold, they look the same. So like, awesome, we just used like functional programming where I passed a function in and like it came out and people are like, that's awesome. And again, well, I mean, it might be awesome, but it's actually pretty slow. So you can actually do it, you can do the same thing, just say, let's make an expression where we say, take the engagements and divide it by the impressions and alias that as the engagement rate. So this is the same thing, but this, again, is using the expression here to do this, and it's calculating this expression and then pushing that down into the Rust engine and doing that quickly. So I'll just do a quick timing of this. So my function version takes 3 milliseconds. Okay, and apparently when I was running it today, my computer is pretty bogged down. So We'll just do the math here for this. What is that? 330 divided by 76. Yeah, so this is like 50 times, 43 times faster to do this, right? So this is just an example. I mean, in this case, it's like 3 milliseconds. I don't know what 3 milliseconds is versus 76 microseconds. I can't tell, not a huge deal. But you can imagine if you have something where it's like, this is now, instead of taking 10 seconds, it's taking 10 seconds times 40 seconds times 40, right? 400 seconds or whatever. That might be annoying, such that like, you're going to be a lot less productive when you run that now, and you're going to go up and you're going to like go chat with your colleagues or go surf the internet while something's running, rather than having more instantaneous results there. They also use arrow under the, I can't. The comment is, how does that compare with data sets? And I haven't used data sets, so I can't really speak to that. Yeah. And again, if you can be smart about it, right? And you could think of like, oh, there's probably a way to like be smart and like decompile the function and like throw it into a Polar's expression. And there's actually a library that does that for some things. So yeah, I don't know what data sets it's using though, so I can't really comment on that. Yeah, I think my warnings are turned off here, but if you do map elements, it might complain to it, and it says like, hey, you're being dumb here. Don't use map elements unless you absolutely have to. So that's kind of nice, telling you when you're being dumb. Okay, so the last section here is aggregations. So this, I call this the stuff that your boss wants, right? So if you imagine you work at like a candy store, your boss comes in and says, how are we doing today? Your boss doesn't want to know that Billy came in and bought a Tootsie Roll and a lollipop, and then Sally came in and bought a pack of gum and 2 jelly beans. Your boss wants to know 58 people came in today, right? They spent $2,500. The average purchase size was $37, right? If you think about those are basically taking some piece of data and collapsing it. It's doing an aggregation. So I think aggregations, these are the things that like people who know how to do these with Excel, their bosses tend to like them. And you can do these with polars or pandas as well. And you can probably do fancier things than you can do with Excel in these. So let's assume that like I want to compare impressions by response, whether it's like an original tweet or a response to someone by month. How would I do that? And the first thing to do is like get a month column. So I'm just gonna, I guess, cheat a little bit. I'm gonna use this stir F time. I'm gonna format the time as a string that has a year and the month in it. So we'll just try that here. Again, I'm building this up with this expression syntax. This is saying I'll have a column called time, and I'm gonna call this stir F time in this, and then you throw that into the context there with columns, and it figures out how to do that. And we should have at the end here a column called month here. So that looks like that worked. Okay, so now I'm going to say let's group by month, and we'll just take the mean of that, and we get something that looks like this. Again, there is no index here in pandas. This is actually pretty similar to pandas. In pandas, you'd have the month and the index here. We don't have that. We just have month there, but this takes every column and gives us the mean. So I don't really know what the mean of the tweet text is, but it says it's null. So leaves those in there. Pandas 2 actually complains about that. Pandas 2 says, I'm not going to do that. And you have to like say that you want numeric calculations on that. Okay, so one thing if you're paying attention, you might have noticed that these dates, and you see I'm running it multiple times, it's actually changing what's going on there. That might be disconcerting to you, like the results are changing. But if you think about that, that's your optimization going on there, right? So a group by something that's trivially parallelizable, like we have these bunch of groups of months and we can run each of them separately. And so it's just calculating them and joining them back in this data frame at the end, and doesn't really care about the order of those, so to speak. So I'm gonna just sort on that after the fact, just to keep those in order. And then, if I run this multiple times, I get the same order there. That is different than pandas. Like pandas is dumb, but maybe that's smart that it sorts them for you if you want that. Okay, so let's do some plots on this. Just loading a style there. So what I'm going to do is I'm going to say, okay, let's group by month, and then here I'm going to do ag. This is again similar to pandas, but I'm going to put expression in here. So I'm going to say pull off the impressions column and do the mean, pull off the engagements and do the mean, and then sort it by month. But you can see that, like, okay, with this syntax here, I can kind of stick in whatever I want in there that's an aggregator, right? It doesn't have to be a single thing. So this is where it can start doing some pretty powerful things. Okay, so here I'm going to plot this. Now, one of the things, it's like the question, like, when do I want to use pandas versus polars? One of the nice things about pandas is that pandas has plotting in it, right? And so it's actually, I find that it's easier for me to plot using pandas than it is to plot using matplotlib. I'd rather just throw something into a pandas data frame and plot it than, like, remember matplotlib's weird syntax for doing things. Polars doesn't have plotting. So they're like, no, we're not, that's going to be maybe an extension or something like that. So, you know, at this point, you know, if you want to plot, we can just say 2 pandas here. And you know, if we run this, that looks familiar to all of you, right? Here's before, and here's the after, right? So that's converting that to pandas. At this point, this is a pandas data frame. We can say, let's plot this. I'm going to stick a month in the x-axis, and then in the y-axis, I'm going to do that. I guess something that looks like that. You know, is that the world's greatest plot? No, not necessarily, but let's sort of see what's going on here. So again, you know, sometime in this time frame, like, it lost a bunch of data because either Elon got rid of it, or I don't know, they had a data center crash. Okay, so you know, and once you kind of understand how this is working, right? You know, if I want the median here, I can just change this to median and get the median, right? Or if I want the standard deviation, I just change that to standard deviation and get the standard deviation of that. So once you understand the pattern, it's pretty easy to change. Okay, get out, stop talking. Okay. One thing is, just be aware that you want to sort that. If you don't sort that month date, you might not be getting the results that you want. So if I don't sort that, that kind of looks right, but due to what's going on here, it's like 2021 is at the end here. That's kind of messed up. And actually, I get different results every time I plot that. So kind of weird if your boss probably wouldn't be happy about that. So let's stick in some code. So this is just overall impressions. Let's be a little bit smarter here. And I'm going to say, I want to know when I reply to someone, what are the impressions like when I reply versus just a straight up tweet here. So I'm going to use this syntax here to make a new column called isReply. And it's just built up from an expression. I'm going to take my tweet text and just say, does it start with the @ If I start with an @ that's a reply. And then I'm going to do a group by here. Instead of a grouping by just by month, I'm going to group by month and isReply. And I'll comment out the plotting part here. And it'll look something like this. So now we have this isReply and month here. You can do the same thing with pandas. You just say reset the index after you do a group by, right? And push the index into the columns there. So again, we can push that into pandas if we want to. We've already sorted it by month, so it should be good there. And then we can plot this. And we get some weird plot that looks like this. And can I plot it without sorting like this? Yeah, the question, can I plot without converting to pandas? So I can comment this out. It does, so polars doesn't, they're like, we're not doing plotting in polars itself. So if that's going to happen, that's going to be an extension or a third party. So this is one thing to be careful of. This is probably not what we want. Like, we see these jaggedy lines here. Basically what's going on is it's like saying, this is the impression, this is the the reply and the non-reply. So I actually don't want that. So let's maybe debug this a little bit here. Okay, so that looks okay, but when I go to pandas, I'm going to put this in the x-axis, and you can see that there's like 2 month entries, and there's a false and a true there. That they're like going back up and down. So it's probably not what I want. So what I want to do is actually do something like this, where I pivot it. And it turns out that you can pivot in polars. Pivot is, again, one of those, like in DuckDB's terms, a pipeline breaker, right? You can't pivot lazily, because what a pivot is doing is it's saying, I want to take the values of a column and rotate them up and make each of them a new column. And you can't do that lazily unless you know what's in the column. And being lazy is explicitly not knowing what's in the column. So you need to materialize before you pivot. At this point, we're not being lazy at this point, so it does that. But you can, and pivoting, I think, is one of those key things. Once you understand how to pivot, it's like superpowers for your boss. They're going to ask you to do lots of things, so don't let them know that you can pivot. Anyway, at this point, we can say, like, stick this into pandas, and then we can plot this. And then I'm just going to choose the columns that I want to plot, like impressions versus is reply versus not reply. Then I'll use some matplotlib to get rid of the legend. Stick that on the side there. Okay, so we get something that looks like that, and you see that, like, sometime around this time frame, I got a lot more impressions. My reply impressions have gone up a little bit, and then there's like that gaping hole where the data disappeared there. Okay, so again, I'm using a chain here to do this, right? A lot of people are like, don't chain, don't chain. This is, again, where you get some speed ups using chaining in polars, because it can be smart about that. Yeah. So the question is, like, once you materialize, you won't optimize. So it's not going to do the query optimization, right? But it can, like, max out your CPUs on a group by, right? I can group by again and can be smart about that. Also, like, I can chain, and then after I do this, I can say, like, make it lazy again. So I can just stick in, like, so like a group by here. I don't know if it supports a lazy right here. It might not, but I can go at some point when I've materialized, I can stick it back in and make it lazy again, and then it will kick off the query planning again. If that makes sense. But, like, pivot, like, if I say this, like, lazy right here, it's going to complain. It's going to say pivot isn't an attribute, because you can't pivot a lazy thing. It needs to break the pipeline to do that. Does that answer your question? Think so? Good enough? Okay. Okay, so this next example is just like saying, well, I'm doing a group by and then I'm doing a pivot. Can I just combine those? And it turns out you can. You can just pivot at the top here. So I'm just going to say, I want to stick into the index month, which is kind of weird, like the syntax here saying stick month into the index. Polars doesn't have an index, but that's the syntax for this, which is very similar to pandas if you use pandas, except it doesn't panda. So another thing that's weird about polars is, like, some of it is modeled after pandas, but they, like, slightly change the spelling of things or insert underscores, which, whatever. I guess if you're using tab completion, it shouldn't matter. Anyway, so in the index, we're sticking month, and then I'm going to pull the column is reply, so that should put true false up in the columns. And then what am I going to aggregate? Impressions, and the aggregate function is going to be the mean function. And then I'm just selecting the month and the true column there, which is whether it was a reply or not. And then I'm sorting that and sticking that into pandas and plotting that, and it should look basically the same there. And I'll stick my legend off on the side. Okay. So in summary, I think polars fixes a lot of the issues of pandas. Again, I think that challenge right now is that pandas has a lot of momentum and mindshare, right? And a lot of people are like, we're going to use pandas. It's like the IBM. So I think polars has you know, they're sort of saying the right things, their code is doing the right things. I think what people, as far as like fixing a lot of Pandas bugs, there are a few Pandas core developers who are actually core developers on Polars as well. So if that tells you anything. So general summary here, if you use the correct types, you can save space. Again, I was reading from CSV files, but you can export to Parquet or Feather. And then if you do that, then you will get quick loading of your data, and generally it will be of the right types. Again, highly encourage chaining in both Pandas and Polars. Polars is actually going to take advantage of that and can be smart about that. Don't use apply or map elements unless you really know what you're doing. And then play around with those aggregations, and hopefully they'll make your life better. Okay. So I wanted to do a giveaway here at the end. I'm actually running a course next week, and the course is, it's called Beyond Pandas 1, but basically we're going to meet Monday, Wednesday, Friday for like 90 minutes. The first class is going to be on Pandas 2, talking about the new things in Pandas 2. The second class is going to be on Polars, and the third class is going to be on DuckDB. So DuckDB, anyone in here use DuckDB? Okay, yeah. So DuckDB, I think, you know, maybe going back to that question about, you know, should I use Polars? I think DuckDB is another option that there are pros and cons to it. But DuckDB is generally faster than Polars, and DuckDB can do pivots and basically can do, if you sort of squint at like the data frame API, DuckDB can do a lot of the things that Polars and Pandas can do as well. And it has pretty good integration with Python. Again, you're writing SQL there. It does have a Python functional API as well. Another interesting thing about Duck is that they have, they're implementing the Spark API on Duck, which is kind of interesting. Again, that notion that a lot of people sort of said, oh, we're going to use Spark and Hadoop because we want to be cool like everyone who's using Spark and Hadoop are. And then they found out like it was kind of overkill for what they need. And so they're kind of doing the reverse of that company that I was advising for, which is saying we're going to put Pandas on Snowflake. They're saying we're going to put Spark on small data. So they're re-implementing, they want to have 100% API coverage, but basically run your Spark stuff smart and intelligent on a single node. So anyway, so I'm going to give away access to one person for that course, but I don't want to just give it away to someone who's not going to use it. So is there anyone in here who would be interested next week to attend that? 2 people? Okay. Okay, so we'll do a raffle for 2 people for that. So I'm gonna say import random, and we'll say random. I guess we can do choice here. What do you want? What do you want your number to be? 1? You didn't do 42? Bad choice. Okay, 1 and 0. Let's see if I can get this to work. 0 and 1. Okay. Okay, 1 wins. Talk to me after, and I'll get you enrolled. Okay, and then I brought some books here as well. I brought some machine learning books and my Effective XGBoost book. So I guess we'll just raffle off those to everyone. We'll just go by table here. So table, I'm just going to count these off. Your table, we'll count by 0. 0, 1, 2, 3, back there, 4, 5, 6, 7, 8. Okay, so remember what table you're on. We got 5 of those. So random. So we got 8 tables. So I'm going to do rand range. Python follows a half open interval. So that means it includes the first and doesn't include the last, which would be, if we say 9, it will go up to 8, right? 0, 1, 2, 3, 4, 5, 6, 7, 8. Okay, here we go. Table 5. 0, 1, 2, 3, 4, 5. That's that table, our contestants there. Okay. Okay. I'm gonna disqualify my friend who's going to the course. So we're gonna do here 0, 1, 2. Okay. Okay, 0. So you can come get a book. Okay, I've got 5 books, so we'll do this again here. 7, 6, 7. Okay, 0, 1, 2, 3, 4, 5. 5. Black shirt, yeah. Okay. Next one is 4. Back there, we got 2 of you. Okay, 0. We should have named who you were. Let's do it again. 0, 1. Okay, 0. Okay, let's do it again. 1. That's this right here. 0, 1, 2. 1, middle guy there. We'll do it one more time. 4. 0, 1, 2, 3, 4. Okay, you can come up and get one. 8 over there. Okay. Okay. 6. 0, 1, 2, 3, 4, 5, 6. Did I not do this table? Have I done every table but this one? Have you guys got one? Okay, we're going to do 2 tables. The table countdown. The battle of the tables. Okay, 0 and 1. Here we go. 1. Okay, 0, 1. Okay, there you go. Okay, thanks everyone.